So the scientific community had established a consensus that burning fossil fuels will lead to climate change. But there was a lack of consensus for when we would see climate change. Establishing this consensus, in part to drive public policy to mitigate climate change, was crucial, because the scientific community recognised that the impact on society would be profound. So scientists set about determining when these changes would be likely to occur. Most scientists at the time thought that changes would not begin to become detectable until the 21st century. Determining when climate change would be detectable required sophisticated climate models, mathematical descriptions of the climate programmed into computer models. These models coupled atmosphere and oceans and were forced by changing amounts of greenhouse gases, both known and predicted. The predicted changes gave rise to different future scenarios of greenhouse gas emissions. The key to knowing when climate change would be detectable was estimating the natural climate variability. In 1988, James Hansen and co-workers published a seminal paper in which they provided the first estimate of this variability. Hansen used observed surface temperatures to argue that this variability in global average temperature was about 0.13 degrees Celsius, such that an observed rise of about 0.4 degrees Celsius in the global average would give a 99% confidence that global warming had been observed. He argued that this would constitute convincing evidence of a cause and effect relationship, i.e. a smoking gun. He further found that his model results showed a similar variability, which gave credence to the model's predictions of climate change. Although Hansen's 1988 paper predicted that this 0.4 degrees Celsius threshold would likely be witnessed within a few years in the 1990s, Hansen testified before the US Congress that global warming was happening now. This emergent recognition that climate change was not some abstract phenomenon that might materialize in the 21st century, but an observed fact happening now, at least in the opinion of Hansen, was quickly followed by further studies conducted by other scientists using different climate models. These studies needed to be systematically evaluated, and in 1988, the Intergovernmental Panel on Climate Change, or IPCC, was formed to do exactly that. The IPCC is an intergovernmental body of the United Nations mandated to provide objective scientific information relevant to understanding human-induced climate change, its natural, political and economic impacts and risks, and possible response of options. It published its first assessment report in 1990, in which they stated global mean surface air temperature has increased by 0.3 to 0.6 degrees Celsius over the last 100 years. They further noted, the size of this warming is broadly consistent with predictions of climate models, but it is also of the same magnitude as natural climate variability. However, in their second assessment report, published in 1995, the IPCC noted that the balance of evidence suggests a discernible human impact on global climate. In the half-decade between the two reports, the scientific consensus had shifted from an understanding that the greenhouse effect is well understood, greenhouse gases are increasing due largely to human activity, and therefore should lead to significant global warming, though lack of understanding limited specific regional predictions, to a greater understanding, despite continuing uncertainties, that global warming continues and is most likely due to human activity. In the third assessment report, published in 2001, the IPCC stated that human activities are modifying the concentrations of atmospheric constituents that absorb or scatter radiant energy. Most of the observed warming over the last 50 years is likely to have been due to an increase in greenhouse gas concentrations. In these assessment reports, this systematic review of the scientific literature revealed the scientific consensus was that human-induced climate change through burning fossil fuels was identified in the observational record. It does seem strange that following the third assessment report, doubt and skepticism of this scientific consensus arose in the public arena. How that doubt emerged will be the subject of the next lecture. But let's consider the changing public perception in the US. The Gallup Environment Poll showed that in 1997, only 48% of the US public believed that most scientists believe that global warming is occurring. However, this figure rose sharply, such that some 61% of the US public believed this by 2001. This number rose still further to 65% by 2006, but dropped dramatically to 52% by 2010. The number in 2021 is still only 68%. I would argue that this poll is a measure of the US public's perception of the scientific consensus around climate change. Is this reflected in the published, peer-reviewed scientific literature? The first attempt to determine the level of scientific consensus in the published peer-reviewed scientific literature was conducted in 2004 by Naomi Oreskes, the co-author of the book Merchants of Doubt. Oreskes found that in the 928 papers published in the 10 years between 1993 and 2003 that talked about global warming, not one rejected the scientific consensus. Indeed, in a later study of the scientific literature by John Cook and co-authors in 2013, and in a survey of 11,944 abstracts from peer-reviewed journals, 97.1% agreed with the scientific consensus that human-induced climate change is real and happening. There is a disconnect between the public perception of the level of consensus present among scientists studying climate change and the consensus among scientists themselves. This scientific consensus is represented in the reports of the IPCC and is the position of every national and international scientific body. It is always possible that the scientific consensus might be wrong. If the history of science has taught us anything, it is humility. Many details about climate interactions are not well understood, and there are ample grounds for continued research to provide a better basis for understanding climate dynamics. The question of what to do about climate change is also still open. But there is a scientific consensus on the reality of human-induced climate change. Climate scientists have repeatedly tried to make this clear. Doing nothing is not an option. Thanks for listening.